The role of quality assurance. The need for quality assurance. Quality is defined as meeting agreed customer requirements, and quality management aims to achieve this at the lowest overall cost. For an engineering project, the ultimate customer is the asset holder, but there are also internal customers, such as the fabricator, who is a customer of the designer. Management systems are essential to assure technical integrity, as quality failures can result in cost and schedule overruns, higher operating costs, and increased safety or environmental risks throughout the lifecycle. Operational quality failures also have significant cost and risk implications. Therefore, a QA approach forms the basis for sound HSE, health, safety, and environment, and general operations management. Furthermore, there is an increasing need to make business management transparent to regulators and other stakeholders. This document provides guidance to all staff involved in setting up project management systems or evaluating a contractor's or supplier's system. The principles apply to managing any project aspect, including safety, environment, organization, information, cost, budget, and schedule. Link with quality management. Quality management consists of three interlinked elements: quality planning, quality control, and quality improvement. The overall aim for a company is to achieve continuous performance improvement through managing the underlying business processes. For individual projects, the emphasis is on quality assurance, QA, which combines quality planning and quality control. Lessons learned during project execution are fed back into the organization for future improvements, and may also be incorporated into the current project. The ISO 9000 standards. The ISO 9000 standards for quality assurance are widely applicable, but written in a general way, identifying some 20 elements that make up a complete system for a company. These standards help ensure that the organization's quality management system is comprehensive and effective. Implementation of quality assurance. Activities. Not all elements will apply to a particular project, but all projects shall have QA input and a project quality plan, which is part of the execution plan for the project. To maintain asset quality and achieve its objectives, a project should organize itself to control technical, administrative, and human factors affecting product quality. Control should aim at reducing, eliminating, and preventing quality deficiencies. A well-structured quality system enables management to optimize and control quality in relation to risk and cost benefit. The management system is documented in the project quality plan, addressing critical activities such as determination of customer needs, definition of methods to achieve these needs, assessment of the criticality of activities and products, allocation of responsibility and definition of controls, generation and maintenance of quality records, QA audit and review. Quality improvement. Staff quality, like safety, is the responsibility of line management and every individual working on the project. Competent and motivated staff, supported by a well-understood system of working, are crucial for success. Depending on the project size, they may be backed up by dedicated or corporate QA staff who must retain a high degree of independence and objectivity, reporting directly to the project manager and functionally linked to the corporate quality organization. Typically, QA staff are responsible for coordinating the preparation of the project quality plan, assessing potential suppliers and contractors' quality systems and quality plans, monitoring the implementation of the project quality system, monitoring activities of contractors and suppliers in implementing their quality plans, gaining regulatory permits for the project, executing audits and reviews, and following up on any actions arising from them. Inspection responsibility often falls under engineering rather than QA staff, and project document control should be handled by administrative staff. Documentation. Formal QA is fully documented. Critical activities are performed according to written procedures or work instructions based on proven techniques, and compliance evidence is recorded. It is essential that engineers, with the operators, exercise proper judgment in deciding which hardware systems and activities are critical. Over-control costs time and money, adding to the paper mountain handed over to operations. Quality can often be assessed by controlled sample checking. Complete validation is not always necessary. Once an activity is established as critical, The control method is decided by the responsible engineer, who specifies the necessary standards and documents management controls, e.g., design reviews or inspection. If a new procedure is required, guidance is provided in Appendix B. QA activities are incorporated into the project work scope and are scheduled and monitored through the quality plan. Quality assurance of project management, the quality plan. All projects shall have an approved project quality plan prepared at the start of the project by the project engineer and updated to include more detail as the project advances. Site-specific plans should be prepared prior to starting activities on a construction site. The project quality plan is a documented description of the project management system and must be approved by the project manager or engineer, in part to demonstrate his commitment to quality, but primarily since it is the means by which technical and administrative authorities are delegated throughout the project. It draws together the key documents which describe the objectives of the project, identifies the critical activities, and defines the controls required to ensure that the project quality objectives are met. Project quality plan, project objectives, objectives to be achieved, criteria requiring to be satisfied including HSE targets, governing regulations and standards, description of measures to achieve the objectives quality system, project or OPCO quality policy and purpose scope of the quality plan, organization responsibilities, resources, skills, training, contractors, suppliers, equipment, facilities, procedures and controls matched to critical activities, description of the responsibilities and schedule for audits and reviews. The quality system should only be as comprehensive as needed to meet the project objectives. On major standalone projects, the very nature of the project demands that it is supplied with the necessary levels of expertise and that the relevant controls and plans are in place. However, in the multi-project environment, less experienced staff are often placed in decision-making roles, and reliance is placed upon the use of standard procedures. Experience has shown that such procedures are often ignored for a variety of reasons, e.g., pressure of work, conflicting priorities, non-availability of third parties, etc. The management system, as documented in the quality plan, overcomes these problems by ensuring that the review cycle is adequately planned, has third-party and management pre-commitment, and provides well-documented records which give an audit trail. It also ensures that records and handover documentation are properly planned and completed during the work. In a multi-project environment, such quality plans may be prepared in a standard format. Preparation of a quality plan. The plan should include the following elements: objectives, resources, and constraints. Formally agreed objectives with the ultimate asset holder, properly recorded and communicated to all. Definition of any constraints arising from regulators, special environmental factors, the need to use certain technology, etc. Plan the project and allocate responsibilities. Develop a high-level project plan and allocate each activity to an accountable person, included in a written job description. Identify critical hardware systems and activities. Define standards, controls, and performance indicators. Summarize critical activities in a table, including details of responsibilities, standards, methods of verification, and records. Plan QA reviews and audits. Audits to be carried out by QA staff included within the project plan, since the actual dates of audits will depend upon project progress. Closeout reporting. Feedback of lessons learned into the organization is crucial to improvement. Closeout reports should be prepared progressively during the project and include sections at the end of conceptual and detailed design phases. A post-implementation review should be undertaken after all major projects to provide information for future project improvement. Quality assurance for contracts and procurement. Selecting the appropriate quality program. The objective of implementing a quality assurance approach for work done by others is to ensure that the equipment or service supplied complies with specification, reinforce the contractor's awareness of their responsibility for the work, minimize the principal's involvement and hence principal's costs, minimize delays to schedule caused by the use of excessive hold points, produce evidence of compliance, the audit trail, and measure contractor-supplier performance. In deciding the degree of assurance required for an activity or an item of hardware, the risk of failure needs to be established. This includes consequences of failure, what happens if it goes wrong, probability of failure, how likely is it to go wrong. A procedure shall be devised to score rationally the relevant factors and thereby establish a combined measure of criticality. ISO 9001 utilizes product and process factors which address the probability of failure. These factors include complexity of designing, ISO, maturity and stability of product designs, ISO, production process complexity, ISO, product characteristics, ISO, nature of work, organization of work, work location. By summing the scores for each factor, a rational choice of contract QA program requirements can be made and specified in the contract or purchase order. A typical program might include ISO 9000 quality system. Contractor is required to operate a quality system in accordance with ISO 9001 series. Formal quality plan. A dedicated contract quality plan is required, specifying all the contract quality activities. Work plan with inspection. Contractor prepares for principals agreement, including work method description, and an inspection plan detailing scope, method, frequency, timing of inspections, and acceptance criteria. Work plan with final inspection only. Contractor prepares for principals agreement, including work method description and an approved plan for final inspection, detailing scope, method, and acceptance criteria for final inspection. Principals acceptance of work. Contractor states formally that the work has been completed in accordance with the contract requirements, and the principal confirms the work has been performed. Monitoring performance. Performance monitoring ensures compliance with quality standards and specifications. Key controls include appraisal of all suppliers prior to inclusion on the bidder's list, preparation of requisitions in an agreed format, full technical and commercial review approval of requisitions before issue, a clear evaluation plan to review all aspects of the bid, technical and commercial focal points responsible for bid clarification, award recommendation, and negotiations, preferably remaining responsible until closeout. Change control during the order currency. Responsibility for expediting materials and vendor data, highlighting technical problems for early resolution. Purchaser inspection responsibilities clearly defined. Quality audits and reviews. Regular audits and reviews ensure ongoing compliance and identify areas for improvement. Audits should be planned and executed according to the project's critical activities, with findings documented and corrective actions taken as necessary. Control of deviations and concessions. Deviations from specifications and standards must be controlled to maintain quality. Procedures for handling deviations and concessions should be clearly defined, with approval required for any changes to ensure they meet quality requirements. Corrective action. Corrective actions address identified quality issues. The process includes identifying the root cause, implementing solutions, and verifying the effectiveness of the actions taken to prevent recurrence. Control of standards. Standards control ensures that the correct standards are applied and maintained throughout the project. This involves regular review and updates to standards, as well as training and communication to ensure all project personnel are aware of and comply with the relevant standards. Document control. Effective document control is critical for maintaining quality. This includes ensuring that all documents are up to date, properly filed, and easily accessible, defining procedures for document creation, review, approval, distribution, and revision, maintaining records of all quality-related documents, including specifications, inspection reports, and audit findings. Document verification and approval. Verification and approval processes ensure that all documents meet quality standards before they are issued. This involves thorough review by qualified personnel and formal approval to confirm that documents are accurate and complete. By implementing these quality assurance measures, projects can ensure that contracts and procurement processes are effectively managed, reducing the risk of failure and ensuring that quality standards are consistently met. Design quality assurance, basic quality objectives. Key project parameters and objectives shall be defined in the field development plan and subsequently amplified in the basis for design project specification and agreed with the future operator. They include performance requirements, e.g. through product and waste stream specifications, production availability, statutory requirements, safety, operability and maintainability, field or plant life expectancy, extendability and flexibility, compatibility with existing facilities. Specification control. Equipment and materials should be specified in accordance with group standards, company standards, or project specifications. Where manufacturer standards deviate from company or group standards, the lifetime cost of accepting such standards should be evaluated before being considered for acceptance. Quality requirements in a specification include functional specification of performance, operational maintenance requirements, and environmental conditions. Statutory regulations, essential additional QC requirements, group standards, documentation requirements, submission of quality plan. Specification control ensures each specification is complete and has been verified, complies with other specifications, is compatible with interfacing specifications, contains the necessary quality requirements. All specifications and standards shall be rigorously vetted to ensure their applicability. Deviations from specification shall be controlled and a deviation register kept for handover to the asset holder. Interface control. Major interfaces exist between disciplines, structures, contractors, modules, operations, and projects. Interface control aims to eliminate or minimize errors caused by mismatches between different elements of the work, which is a major responsibility of the project team coordinating various contractors and suppliers. Engineering change controls. Changes to the design must be controlled to prevent unauthorized alterations. The process includes reviewing and approving design changes, documenting changes and their impact, communicating changes to all relevant parties, ensuring changes are reflected in all related documents and systems. Design review. Regular design reviews are essential to ensure the design meets all requirements and standards. The process involves reviewing design documents and drawings, verifying compliance with specifications and standards, identifying and addressing potential issues, documenting review findings and actions taken, reliability, operability, maintainability, or engineering. Reliability, operability, and maintainability should be integral parts of the design process. This includes defining reliability targets in the specifications for process, service, and safety systems, considering spare items or capacity for major equipment to ensure overall plant availability, designing controls to minimize the chances of maloperation, especially for emergency shutdown systems, preparing detailed operating procedures and undertaking operator training before startup, estimating lifecycle operating costs to justify investments in operations and maintenance features. Design contractor appraisal and evaluation. Prospective design contractors should be appraised before inviting tenders, considering factors like experience and track record, including HSE performance, quality system equivalence to ISO 9001 HSE management system. A quality plan must be included in every design contract, specifying requirements for the quality system and plan and incorporating the agreed quality plan into the contract. Software. Controls for software ensure calculations and analysis are performed using authorized software, and results can be traced to the software and version used. Key controls include validation confirmed by a validation certificate, including manual spot checks and the production of a user's guide. Authorization of users by supervisors to confirm understanding of the software. Formal registration of all software versions in use. Weight control. For offshore projects, weight targets should be estimated early in the design using historical data. Weight estimates should be updated as more information becomes available, and weight trend reports used to assess deviations and take corrective actions. By adhering to these principles of design quality assurance, projects can ensure that designs meet all specified requirements, maintain high standards of quality, and mitigate risks associated with design changes and interface issues. Procurement quality assurance. Appraisals establish the capability of a supplier to deliver goods or services to required standards. The tender list should be restricted to suppliers and contractors whose capability has been previously established with regard to quality systems, technical know-how, production capacity capabilities, financial status, HSE record. Appraisals may be carried out in stages. 1. Review of historic data. Review records of previous contracts or appraisals. Industry bodies in some countries carry out assessments of suppliers' quality systems and provide certification to confirm their acceptability. 2. Review of documents. Review documents provided by potential suppliers. 3. Formal appraisal visits. Conduct interviews with staff and on-site reviews of the supplier's management system to ensure the required controls are in place according to the relevant ISO standard. All suppliers on a tender list should operate a satisfactory quality system equivalent to the appropriate ISO 9000 series standard. Procurement control. The objective is to ensure the order is placed with the most suitable bidder and that the materials or equipment and documentation are provided to the correct specification on time. Key controls include appraisal of all suppliers prior to inclusion on the bidders list, preparation of the requisition to an agreed, preferably standard format, full technical and commercial review approval of requisitions before issuing to ensure completeness, a clear pre-agreed evaluation plan to review all aspects of the bid, technical and commercial focal points responsible for bid clarification, award recommendation, and negotiations, preferably remaining responsible until closeout. Incorporation of QA and QC inspection requirements in purchase orders, matching the criticality of the supplied items. Clear responsibility for expediting materials and vendor data, and for highlighting and resolving technical problems before they lead to delays. Defined responsibility for purchaser inspection, whether by principal or specialist contractors. Quality control QC. Suppliers must take full responsibility for the QC of their products. Supplier performance may be monitored through periodic auditing of compliance with the contract or purchase order quality plan, surveillance by resident or visiting inspectors, witnessing of inspection and tests, review of QC documentation, audit of QC procedures. Materials control, procurement. The objective is to ensure all material and equipment is properly identified, verified as conforming to specification, properly documented, preserved, and stored. Key controls include purchase specifications requiring suppliers to provide sufficient protective materials during transport and field installation. Procedures to check incoming materials and documentation against purchase order requirements, ensuring they are free from damage, corrosion, and properly preserved. Quarantine procedures for unidentified, doubtful, or damaged materials. Traceability procedures to allow materials to be traced back to batch documentation, identification marking of items, and records. Records of transfer of ownership of material from principal to contractor or vice versa. Appraisal and use of inspection contractors. Inspection contractors may be engaged to verify the quality of supplier products. The project team should establish that the contractor operates an effective quality system in accordance with ISO 9000 and has the competence, resources, and integrity to fulfill the task. Individual inspectors should be interviewed and tested. Inspectors should have up-to-date copies of the purchase specifications and the supplier quality plan. They should attend pre-inspection meetings with the supplier to ensure all parties are familiar with the requirements and agree on hold and witness points, which should then be included in an agreed revision to the quality plan. Inspectors must be copied with all changes to drawings, specifications, etc. By implementing these procurement quality assurance measures, projects can ensure that contracts and procurement processes are effectively managed, reducing the risk of failure, and ensuring that quality standards are consistently met. Construction and commissioning quality assurance, prefabrication, construction control. Contractor appraisal is described with supplier appraisal. Quality management of construction should be based on the following contract strategy. The job specification includes the QA requirements for the contract. The tender list is restricted to formally approved contractors with satisfactory quality systems equivalent to ISO 9000. Tenderers submit a quality plan with the tender. After review by the principal, an approved quality plan is included in the contract. Contractors' QA is self-implemented and monitored by the project team. When due to local circumstances, it is impractical to qualify contractors in this way. Each tender should be weighted according to the assessment of the additional surveillance required to provide assurance. The objectives of construction control are to ensure that the work complies with the appropriate specifications in a safe and workmanlike manner. The work is verified using previously approved techniques and personnel, with verification at agreed points in the construction process. Quality verifying records are generated and maintained as the work progresses. Main contractors impose a suitable level of control over their subcontractors. Contractors are fully aware and accept full responsibility for the compliance of the work with the applicable specifications. The initial task is to select the appropriate control techniques depending upon the criticality of the work. For a major construction project, a combination of 4 techniques will be employed. 1. Formal inspection or verification of the work. Only adopted where the effect of a failure caused by an error would pose an unacceptable safety risk or affect the viability of the overall activity. Examples include pressure testing of pipelines, leveling of compressors or generators, and major lifts of over 100 tons. The performance or verification of such activities shall be witnessed by the principal, and the contractor shall not be allowed to proceed unless given written approval. 2. Performing technical system and compliance audits. The objectives and performance of audits and reviews of critical activities are described. The contractor's quality plan shall be reviewed and the audits to be witness selected. A brief report shall be prepared after each audit. 3. On-site patrol inspection of the work. This technique is used to verify that the work is being performed to the appropriate work instruction using the correct equipment and in a suitable environment. Is being performed by individuals who are suitably qualified. Complies with the technical requirements at each stage of completion. Verifying activities are performed in accordance with the quality plan. Construction material control. Ensure the contractor has procedures to ensure that material received is properly identified for traceability if required, undamaged and properly documented. Stored material is adequately protected and its identification clear. Material released for construction is as specified and in good condition. Preservation procedures are applied during construction to maintain material identity and quality. Inspection contractor appraisal. Inspection contractors may be engaged to verify the quality of construction. The procedures herein should be used to establish whether the contractor has the competence, resources, and integrity to fulfill the task. Individual inspectors offered should be interviewed and tested for competence. Commissioning control. The objectives are to ensure that the asset is brought into production, to a plan which allows individual systems to be progressively commissioned, without risk to the safety of personnel or the environment and minimal disruption to existing facilities, with the necessary permits or consents from authorities and with auditable records, with any necessary changes having been suitably authorized and recorded. The key controls are preparation of a detailed plan to ensure that support systems are completed prior to the production systems. Energized electrical systems or pressurized pipework do not present a hazard to construction or operational personnel. Commissioning spares and any temporary equipment required are procured. The handover is properly planned and agreed. Commissioning personnel are suitably qualified and experienced. Commissioning procedures are prepared to ensure that a sequential commissioning procedure is developed and approved for all systems and subsystems. Mechanical completion of systems should be confirmed by the completion of checklists prior to handing the system over for commissioning. As-built records are maintained and records kept of all readings taken or adjustments made to the plant. All requests for concessions and deviations and changes to the asset are properly approved. Statutory authorities are provided with information when necessary, e.g., at startup. Commissioning records shall be maintained in a retrievable form containing checklists, calibration records, concession requests, as-built drawings, completion certificates, and punch lists of any outstanding work. Commissioning activities shall be verified by formal review of the systems and procedures in place prior to starting the work, witnessing and countersigning of critical activities within the commissioning process, performance of spot checks on activities considered to have lesser criticality. It is necessary to verify that the installation has been constructed as designed, meets its performance specification, is safe and reliable for operation. Design limits have not been violated. Handover control. The objective of implementing a control system for the handing over of assets is to ensure that both parties are aware of the extent and any limitations of performance or completion of the asset at the time of handover. The handover is achieved to a schedule that is acceptable to both. Documentation and other information are of an agreed type and format. The key controls are: a handover point is to be agreed, either a single milestone or a series of system-by-system transfers accompanied by handover certificates. In the latter case, procedures are necessary to control the interface between the remaining workforce and the live operation. A hazard register describing the HSE threats and the controls required to address them throughout the life cycle of the facility. This is the prime input to the HSE case for the asset. Punch lists of any incomplete items and associated costs are to be compiled and mutually agreed. A document detailing the types and numbers of documents, computer files, microfiches, etc., to be handed over shall be compiled and agreed upon between both parties prior to the transfer of any material. Subsequently, the actual handover progress can be monitored against this. A QA check on the following is required: completeness of as-built drawings, records, and specifications, availability of supplier documentation for all equipment, operating and maintenance procedures which also include experience gained during commissioning,